Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 3 based on the transformers, self-induced EMF and mutual-induced EMF. So question is as follows that two identical coils A and B having 1000 turns are wound on a common magnetic pole. Okay, then 60% of the flux of each coil is linked with the other coil. E current other coil A, okay, current of the 5 ampere in a coil A produces a flux of 0.05 into 10 raised to power minus 3 Weber. Okay, so there is a condition. If the current in a coil A is changed from plus 6 to minus 6 ampere in 0.1 second, then determine the induced EMF in a coil B. Also determine the self-inductance of each coil and their mutual inductance. Okay, so this is what question asked. So let's solve this question. So here N1 is equal to N2. Okay, so identical coils which is equal to 1000. This is given to us. Okay, when here I1 is 5 ampere, phi1 is here 0.05 into 10 raised to power minus 3 Weber. Okay, I am assuming coil A as a 1 and coil B as 2. So I1 means coil A. Okay, and if I calculate the ratio of phi1 divided by I1, which is equal to 0.05 into 10 raised to power minus 3 divided by 5, then I will get 10 raised to power minus 5 Weber per ampere. Okay, so here there is a condition that since coils are identical, okay, that means L2 is equal to L1, okay, and which is equal to L, self-inductance. So we know that formula for the primary side inductance or the primary self-inductance, which is equal to N1 multiplied by phi1 divided by I1. Okay, so this ratio we have already calculated here. So which is equal to the value of the N1 is 1000 into 10 raised to power minus 5. So this is how I get the value of the L1, which is equal to 0.01 Henry. Okay, so here L1 is equal to L2 and L2 is equal to 0.01 Henry. Okay, so this is our self inductance. Okay, next thing is that here we need to calculate the mutual inductance of coils. Of coils. Okay, so we know the formula for the mutual inductance is equal to N2 multiplied by phi2 divided by I1, so which is equal to N2 into, there is one condition is given in the question is that here that 60% of the flux of each coil is linked with the coil A. Okay, so that means phi2 is equal to nothing but the 0.6 time of phi1. Okay, and divided by I1. So now this value is equal to 0.6 multiplied by 1000 multiplied by 10 s to power minus 5. Okay, so we have already calculated this ratio, okay, which is multiplied by 0.6 and 1000. So this is how I get the value of the mutual inductance, which is equal to 0.006 Henry. Okay, so this is our another answer. Now there is one condition which asked in our question is that therefore induced EMF in a coil P when current changed from plus 6 ampere to minus 6 ampere. This is what asked in the question. Okay, in this is minus in 0.01 second. So what that means? That means that E2 is equal to, we know the formula is that minus of I1 dI1 divided by dt. So that means we have calculated the value of M, which is equal to negative of 0.006. Okay, multiplied by minus 6. Okay, that means change from 6 to 6 ampere divided by dt. Okay, which is equal to time 0.01. So the value of the induced EMF in the coil B, which is equal to E2, is now 7.2 volts. If you solve this, you will get the value of 7.2 volts. So this is how we have calculated the value of the induced EMF in coil B. Okay, coil B means E2, induced EMF. Okay, so this is how we have calculated the parameters which asked in the questions. Okay, so thank you very much. Please like and subscribe our channel.